So Rick decides to take a walk and moves 40 meters east, then 50 meters north, and finally he takes a direction 60 degrees east of north and walks 30 meters. And the question is, what is the net displacement and the angle from the starting point? So let us first label this as north and this as east. So Rick first moves 40 meters east. So if we label this as vector A, we can say the magnitude of vector A is 40 meters and vector A can be written as 40i. Then he moves 50 meters north like this. So let us label this as vector B, which has a magnitude of 50 meters and it can be written as 50j. Then he moves 30 meters at an angle of 60 degrees east of north. So here it is a bit of understanding the English rather than the physics. So this basically means he is moving like this, or at an angle of 60 degrees that you can see is towards east of north. So this therefore makes an angle of 30 degrees with the horizontal x-axis. So let us call this vector C, and to find vector C in coordinate notation, all we need to find are its position on the x and y axis or the x and y components. And once we know these components, we can just add them to present vector C in ij notation. So projection of C on x-axis would be 30 cos 30, which is equal to 30 root 3 by 2, or we could say this is 15 root 3. And projection of C on y-axis would be 30 sine 30, which equals 30 into 0.5, which equals 15. So vector C in coordinate notation is C is equal to 15 root 3i plus 15j. Now let's find Rick's net displacement by adding vectors A, B and C, and let us call it vector R. Recall, if you add two vectors, the resultant vector starts from the tail of the first vector and ends at the head of the second vector. And here also we can see that vector R starts from the tail of the first vector and ends at the head of the last vector. So R is equal to 40i plus 50j plus 15 root 3i plus 15j. And if we simplify this, what we get is vector R is equal to 66i plus 65j. So now things are a lot easier because we know what vector R is, and the magnitude of vector R, that is Rick's net displacement, would be R is equal to square root of 66 square plus 65 square, which equals approximately 92 meters. So you see this displacement or this length is 92 meters, and that's Rick's displacement. And to find the direction of the displacement, we will find the angle theta that vector R makes with the x-axis. So this also is pretty simple. We can see tan theta is equal to opposite side upon base, or 65 upon 66, or theta is equal to tan inverse of 65 by 66, which equals about 44.6 degrees.